out. I know that the technology has been slow today. So here's a theorem that says if I have am is equal to 1 and a has order t mod m, then a to the n is congruent to 1 mod n m if and only if t divides n. And the reason I chose this particular problem to do for you guys is not because I expect you to memorize the problem or anything. I want to show you an if and only if proof. So this is an example of an if and only if proof that you can keep and come back and look at when you take classes next semester. So in an if and only if proof, it sounds all sweet, but it's not, because you have two proofs to do. You first assume that this side is your no, and then this side is your show. And then you assume this side is your no, and that side is your show. So as you're playing around with this, you'll realize doing one of the proofs is easier than the other, and usually people try the easiest one first. So I'm going to assume this part first, and I'm going to show a to the n is congruent to 1 mod m because it's easier. Well, if I assume that t divides n, that's my no. Expand the no means I take, what does that mean? It means that there exists a k such that n is equal to t times k. What I'm supposed to show is I'm supposed to show that a to the n is congruent to 1 mod m. I think my m became an n there. So what is a to the n? A to the n is tk. I just drop it in from my no. But a to the t, I know is congruent to 1 mod m because that's given to me, that t was the order. So a to the t times k, I just raise both sides to the k power of this equation. So from my no, this was given to me, that this was the order of a. So I just take that equation and raise it both to the k power, and I told you it was easy. So I get a to the n is congruent to 1 mod m. So you write down your no and your show for both parts, and you go, oh, this one's easy, so I'm going to do that first. Now I'm going to show the other direction. Assume now that the other part was my no, and I'm going to try to get to the show. So I know that a to the n is congruent to 1 mod m. That's my given. I have to show that t divides n. And this, if you've taken modern algebra, this should be reminiscent of things like Lagrange's theorem, if you got to it, which is beautiful. Beautiful theorem. So that's what we have to show. We know first that t is smaller than or equal to n. How do I know that? Because t was defined to be the smallest positive integer such that a to the t was congruent to 1. So Song, your question was, how do I know the totient function, for example? Well, if t is the smallest one, I know that the totient function's got to be bigger than it. Bigger than or equal to. Worst case scenario, they're equal. So the smallest positive integer is t, so I know that t's got to be smaller than or equal to n, because at best they've got to be equal or n's got to be bigger, by definition of being smallest. So I can expand the n in the division algorithm by division by t. Really, that changes my problem now. I need to show that r is 0. Right? I want to get after this, that r is 0. So I'm going to expand that in the division algorithm, and then plug that division algorithm in. So all I did is I substituted, instead of n, I put tq plus r, and I know that a to the n is congruent to 1 mod m because that was my no. I use laws of exponents, which I hope my pre-calc students remember for the test. And I get that piece right there. And now I'm done, because I know that if a to the t is 1, I know that a to the tq is 1 as well. That was given to me in my previous part that I did, that any raising of it to any other power will also be 1. So I know that a to the tq is congruent to 1 mod m. So I can just drop this guy out like you did with your computational problems. It's the same as 1. So I get 1 times a to the r is congruent to 1, and a to the r is now congruent to 1 mod m. But r is smaller than t. How do I, that's given to me by the division algorithm, right? That whatever I divide by, the remainder's got to be smaller, or else I haven't done my division right. But that's a problem because t is supposed to be the smallest. So that means r's got to be 0. Done. you also have changed because I see you guys going, ah, that's cool. You know, at the beginning of the semester, you're like, shut up already. So that means that T Q's N or T divides N.